Welcome to the deep dive. Today we're
It's easy to overlook, isn't it? But
Yeah.
the numbers are pretty staggering.
Totally. You might think it's just a minor hassle, but we're talking about an industry set to hit what, $4 trillion next year?
That's the projection and the return rates.
Right. About 1 out of every 3 online orders gets sent back. Just think about that for a moment. 1/3.
That massive figure really tells you why this seemingly small thing is, well, a colossal issue. It's almost baked into the online shopping experience now.
It really is.
Mm.
And it creates all these unseen costs and complexities.
Mm-hmm.
And that's why this deep dive really matters to you. Even if you just enjoy the convenience of, shopping from your sofa, all those returns, they cause ripples.
Big ripple.
We're talking the hassle for shoppers, sure, but also incredible pressure on supply chains, getting things to you and then back again.
And the environmental side, too. Plus the economic costs.
Exactly. It's sort of like this hidden fee we all end up paying, in a way, for the ease of buying online.
That's a good way to put it. I mean, just picture what actually happens when you return something. It doesn't just magically reappear on the website.
Right.
There's a whole reverse journey, shipping it back. People have to check it, sort it. There's damage risk.
Uh-huh.
And if it can't be resold easily, it might get liquidated. That's another cost, potential waste. Plus, while that item's tied up in the return process, someone else might have wanted to buy it and couldn't. Lost sales.
Okay, so yeah, we're not just throwing big numbers around for fun. Our mission today is to really understand how one major player, Myntra, is tackling this head-on.
And what's interesting is how they're doing it.
Exactly. They're not just dealing with the returns after they happen. They're actively trying to predict and, well, maybe even stop them before you even click buy.
That's the proactive shift.
And we're basing this on their own research paper, which gives us this fascinating peek behind their digital curtain.
Yeah, it outlines their strategy, and it really contrasts with the traditional approach, which is mostly reactive, right? Dealing with returns once they land back at the warehouse.
Myntra's strategy, as the paper shows, is a real shift. They're trying to get ahead of it using some pretty smart tech.
Deep learning, specifically.
Right. At the heart of it is using deep neural networks to actually predict the likelihood you'll return something while it's still in your shopping cart in real time.
It sounds almost sci-fi, but it's what they're implementing.
So how on earth are they making these predictions? What's the magic?
Well, the paper talks about this hybrid dual model system. It's quite clever, actually.
Hybrid dual model. Okay.
Yeah, so the first part is a deep neural network. Its job is to estimate the overall probability that the entire cart will be returned.
The whole shebang. Got it.
Exactly. So it looks at everything together first. They're not just guessing. They're building this layered understanding of your potential purchase.
Okay, so Model 1 gives a thumbs up or thumbs down, sort of, on the whole cart's return risk. Then what?
Then, if that first model flags the cart as potentially returnable, the second part kicks in.
Okay.
This uses different techniques, gradient-boosted ones, to predict the return likelihood for each individual item within that flagged cart.
Oh, I see. So it gets more granular.
Precisely. It's a two-step thing. Gives them the big picture and then zooms in on the specific items that might be the problem.
That makes a lot of sense because, you might have 5 things in your cart, but only be unsure about one specific dress or pair of shoes.
Exactly. So what data are they feeding these models? That's where it gets really interesting.
I bet. Let's hear it.
Okay, so it's a really rich mix. They combine different methods to understand you, the shopper, and the products. One key piece is Bayesian personalized ranking BPR using matrix factorization.
Okay, BPR, matrix factorization. Sounds complex. Break that down a bit.
Think of it like a super smart recommendation engine, But instead of just suggesting new stuff, it figures out the hidden connections between items you've clicked on, viewed, added to cart, or bought before. It helps understand your underlying taste, even within the current cart. And it's useful even for those less popular long-tail products where maybe there isn't tons of data. It can still find similarities.
So there's like the system's thinking, okay, based on past behavior, these items in the cart seem similar in ways we've learned, so we can make a pretty good guess about whether they'll stick.
Pretty much, yeah. Then they add another really clever layer to tackle maybe the biggest headache in online fashion: sizing.
Oh yeah, sizing roulette, we've all been there.
Totally. So they've developed personalized sizing vectors. They use a skipgram model. It's similar tech to Word2Vec, which learns word meanings from context.
Sizing vectors. Okay, how does that work for clothes?
Well, think about how a size medium from brand X feels totally different from a medium from brand Y, right?
Definitely.
So this model looks at your history clicks, purchases paying close attention to the product category, and, crucially, the size of those items.
Hmm.
Just like word2vec understands king is related to queen based on surrounding words, this model learns how sizes relate to each other for you across different brands and item types based on your past interactions.
Wow.
It builds this personalized map of how different brand sizing tends to fit you. It's moving way beyond generic size charts.
That's incredible. So it's learning my specific fit profile.
Essentially, yes,
Yeah.
based on your clicks and buys. Then on top of these, let's say, smarter techniques, they also use a bunch of more straightforward data points. They call them engineered features.
Engineer feature. Okay, like what? Give us some examples.
They kind of fall into three buckets. First, product level stuff.
Right.
Things like the brand, the category, dress, shirt, whatever, how long the product's been on the site, its own return history score from other shoppers.
Uh-huh.
And even things like, do you have similar items or the same item in different colors in your cart right now?
The bracketing strategy. Buying multiple sizes or colors knowing you'll return some.
Exactly, that's a flag. Then there's cart level stuff. How many items total? What day or time are you ordering? Where is it shipping? Are you on the app or the website?
Okay, makes sense. Contextual factors. And the third bucket.
That's user level, things about you. Your past return count, how much you spend, how often you order, your usual payment method.
Like cash on delivery versus credit card.
Yeah, that can be an indicator. And even broader things they might derive from, say, clustering users, like your general shopping persona, engagement level, or maybe how much you tend to go for discounts.
Wow, okay. They really are building a full picture. Product, cart, user.
A 360-degree view, pulling data from all over. They use standard techniques too, like one-hot encoding for categories, and handle sparse data so it doesn't mess things up.
And all of that gets fed into the deep neural network, the first model.
Yep, all those features, the BPR embeddings, the sizing vectors, the engineered features, they all go into the input layer.
And inside the network, what happens then?
Well, it goes through hidden layers, using activation functions like ReLU, standard deep learning stuff, doing complex calculations to find patterns.
And the output.
The output layer uses something called softmax to give that final probability score. How likely is this whole cart to come back?
Okay, so they calculate this score, super fast you said, while you're looking at your cart. How does that translate into actual action? What do they do with that number?
Right. This is where their return prediction service, the RPS, comes in. It's the engine running in the background.
RPS, got it.
When you hit your cart page, it gathers the online stuff, what's in your cart now, and grabs the offline stuff, the pre-computed user features, product scores, sizing vectors, sends it all to the RPS.
And the RPS uses the trained model.
Exactly. Cranks out that return probability score in under 70 milliseconds. It's incredibly quick.
Wow, less than 70 milliseconds. That's faster than blinking. Okay, so the score pops out, then what?
Then that score gets fed to what they call a decision engine.
Decision engine. Sounds important.
It is. It decides what action, if any, needs to happen based on that probability score. And this is where it gets really interesting for the shopper, potentially. They have a whole toolkit.
A toolkit of actions, like what?
Well, based on that score, they might, for example, personalize the shipping charge.
Okay. So high-risk returner might pay for shipping?
Could be. Maybe a small charge while low-risk users still get it free. Or they could make certain items non-returnable.
Whoa, okay. Non-returnable.
Yeah, but, and this is key, they might offer you an extra coupon or discount on that specific item to make it worth your while.
The trade-off. Take a discount, but you can't send it back. That's clever.
It is. Another option, especially for high-risk carts or items, is pushing their try and buy service more prominently.
Where they deliver, you try it on the spot, and only pay for what you keep.
Exactly. They might also, for users flagged as high return risks, direct any potential refunds back to the platform wallet instead of the original payment method.
Interesting. Keep the money circulating on their platform.
Could be the thinking. They might also restrict payment options, like maybe not offering cash on delivery to users with a very high predicted return probability.
Okay, that makes sense from their risk perspective.
And behind the scenes, this prediction gives their logistics teams a heads up. Advanced warning for potential reverse logistics load.
So they can plan better.
Right. And in perhaps more extreme cases, they might even temporarily show a high-risk product as out of stock to prevent a purchase they feel is almost certain to be returned.
Wow, that's quite assertive. artificially out of stock.
Yeah, it shows how seriously they're taking the prevention aspect. But it's
Mhm.
important, as you said earlier, the specific action probably depends on whether it's the whole cart flagged as high risk or just one or two items in the cart.
Right, the response can be tailored.
Exactly. Whole cart risk might trigger shipping or payment tweaks. Specific item risk might lead to that non-returnable offer or a push for try and buy just for that item.
So with all this complex modeling and these different actions, it must be making a tangible difference, right? What results are they actually seeing?
The paper shares some pretty impressive metrics. The model itself achieved an AUC of 83.2%.
AC, area under the curve. Remind us what that means.
Yeah, it basically measures how well the model distinguishes between orders that will be returned versus those that won't. Higher is better, and 83.2% is quite good. They also hit a precision of 74%.
Meaning when it predicts a return, it's right about 3/4 of the time.
Roughly, yes. And they stress how much better this deep learning approach performed compared to simpler baseline models, especially after adding the BPR insights and those sizing vectors.
Okay, good model performance. But what about real-world impact when they tested these interventions?
They ran live experiments. So with the personalized delivery charges,
Yeah.
they did see a slight dip in the total number of orders placed, which you might expect.
People balking at the fee.
Some did, but, and this is crucial, the percentage of orders being returned dropped significantly by 3%.
3% reduction in returns, that's substantial.
It is. And their analysis showed that the users who were deterred by the fee were disproportionately those who the model had already predicted as having a high probability of returning things.
So it selectively discouraged the riskiest orders. Makes sense financially, even with slightly fewer orders overall.
Exactly. They traded a few high-risk sales for significantly lower return costs.
What about the non-returnable with coupon offer? How did that go?
That saw pretty good uptake. 27% of users who were offered it took it.
Wow, over a quarter.
Yeah. And on average, those users marked about 1.5 items in their cart as non-returnable for the discount. The result? A 4% drop in the return rate for that test group.
4%, that's even better. People are willing to give up the return option for a bit of savings.
Apparently so for certain items. And the try and buy experiment.
How did that perform?
Also high adoption, 40% of eligible users chose it, and for those orders, the return rate went down by 3.7%.
Interesting. So try and buy also clearly helps reduce finalized returns.
Seems so. And beyond these specific interventions, they also mentioned using the data to identify products with chronically high return rates.
And what do they do with that info?
They might deboost them in search results, make them less visible, or in some cases even delist them entirely from the platform.
So it's not just influencing individual transactions, but actually curating their product catalog based on return risk.
Exactly. Cleaning up the offerings. The model also revealed the most predictive features.
Oh yeah, what rose to the top?
Unsurprisingly, a product's own historical return score was huge. Also, cart size, more items, more risk, often, payment type, like we discussed.
Cash on delivery maybe being riskier?
Potentially. Also, the user's own return history, those personalized sizing vectors we talked about, how often the user shops, the price of the product, and those learned product embeddings from BPR, all were strong signals.
Okay, so let's sort of wrap this up. It's really clear from this deep dive that Myntra is taking this very forward-thinking, super data-driven approach to returns.
Definitely. It's a sophisticated application of AI in e-commerce.
They're not just sitting back and waiting for stuff to come back. They're using AI to predict and, crucially, to try and prevent returns before the box even leaves the warehouse.
And it really signals a big shift, doesn't it? Returns aren't just an operational cost to be managed anymore.
No, it's becoming this key area where proactive data science-driven intervention can really impact the bottom line and potentially the customer experience too.
Absolutely.
And for you, the listener, maybe you don't directly see these complex models running, but the potential benefits could be lower prices eventually as retailers slash those massive return-related costs.
Yeah, and at the very least, you get a fascinating glimpse into the incredibly complex machinery running behind your clicks.
Yeah, the logistics and tech are amazing.
So maybe a final thought to leave you with. As these